All right. Welcome, everybody. Welcome to a new series, Intro to WinDbg, or as some of you who know me, I like to say WinDbg, like with that Italian kind of accent there. Before I officially get started here, I do want to throw up just some apologies real quick. I'm fighting a pretty nasty fever past couple of days. The high of my temperature today is 103. So I'm not 100% there, but we'll make it through. So please just be patient with me today as we get through this, and we'll make this the best that we can here. All right, everybody. I think we got whoever's coming in live is probably already here. So officially going to kick this thing off. For those that don't know me, my name is Jonathan Ryder, and I am an author and instructor for SANS. I teach SEC 660 and I authored a course called SEC 670. As you see through my screen share right now, it's a wallpaper that ChatGPT made for the student-facing VM for that course. And I've been teaching that for a few years now, and WinDbg is definitely one of the skill sets that students need to have going through that course. And it's been a blast, and we have a class coming up in April in Orlando, and if you're in that area, it'd be great to have you there in person, and if you're not close to Orlando, it'd be great to have you there virtually as well. And the course focuses on building implants for Windows, leveraging knowledge of C++, diving deep into different methods of injection, stuff like that, privesc, persistence, all that great stuff, and of course, debugging our tool set as well. I'm also in the Maryland International Guard. I'm stationed at Fort Meade. Shout out to anybody in the 175 COS who might be watching this series. Hello to you. So this series, if you are coming over from my Intro to C series, you'll know that throughout the 10 parts of that series, every once in a while, we would bring up debugging, whether it be WinDbg or some other program or whatever, and the importance of that. And so now we are officially kicking off that debugging series. I don't think this is going to be a 10-part series like the Intro to C workshop was. Maybe about 5 parts. We'll see. This is definitely for the absolute beginner. Someone who has never opened up WinDbg before in your life. This is for you. Okay. All right, so you had some prereqs to do before jumping in here. I don't do slides. I hate slides. In fact, if I could teach a whole course for SANS without slides, I would do so. But we know that's not all possible to do, and slides are very valuable. But I don't like using slides for these workshops. So this is going to be all 100% hands-on. So I hope you have a Windows host or a Windows VM. It could be Windows 10, it could be Windows 11. It doesn't matter. As long as you have WinDbg installed, you'll be good to go. All right. So hopefully that's where you are, because that's where we're going to go ahead and kick off this series with here. All right. So wherever you have WinDbg installed, why don't you go ahead and open it, right? And when you open up WinDbg, you'll be greeted with some kind of layout, right? It's a pretty nice UI. I don't know if anybody has ever seen the previous version of WinDbg. I'll call it WinDbg Classic. You'll be presented with this kind of layout. It might not look exactly like mine because I have it arranged in a way that I like for my workflow. Okay, so I'll go ahead and try to give you a proper introduction or orientation to all the things inside of the interface. Now, WinDbg Classic, or the original WinDbg, it gave a way to save your workspace layout, which is kind of nice because you could save that layout and take it with you wherever you need to go. And it was great to have. With WinDbg here, we really don't have that option. At least that option has not been very obvious how to save your workspace layout. And so you have to set it up. But once you set it up, it's remembered, and it should be this way every single time you open up WinDbg on this particular system, which is nice. So what I have here for my layout right now, and I'll show you how to get all these windows open, is just a command window. Okay, so if you don't have some of these windows open, I'll show you how to get those open. Okay, so we have a command window, disassembly window, a memory window, just to kick things off. And of course, at the top, right underneath the title bar, we have some tabs or some menu items, if you will. And each one of these obviously has its own purpose. And inside of all of these, we can click through on File, for example. And by clicking on File, you can see we have some other menu items that we can choose from and take a look at. And by default, it kicks you off at Start Debugging and Recent. And Recent is basically any of the executables or dump files or trace files or anything like that that this instance of WinDbg on this particular machine, like in this case, my VM, has seen over a period of time. And one of the things that you could do is, once you have this recent menu built out, you can go through and pin some of these items like that. I just pinned notepad up here, so it would be persistent. Okay, so yours might be empty. I would expect it to be empty until you start to go through and debug a lot more things on that particular instance of Windows. And inside of this file menu here, underneath of recent, you have something called Launch Executable. And if you go ahead and click on that, you'll see another window pops open here, a little dialog box of sorts. And this is where you have the ability to go ahead and browse to any folder location, any shared drive, stuff like that, where an executable, a dump file, a trace file, or something like that could be located. Okay, so we're not going to go and launch an executable just quite yet. We'll keep going through the rest of the user interface, and then we'll come back to this as we pick an executable to be the guinea pig for today. All right, so this is where you can go ahead and inside of the search bar or the path here, you can type in the path if you know what it is. Even if you don't know what it is, when you start typing out a file path or a folder path, all the options are going to be up here for you. So you could just go through the motions, picking one, up and down arrows, and a backslash, and you can see some of the subfolders here. Okay, so that way you can go ahead and navigate around in case you don't know exactly where something is located. Okay, we'll go ahead and hit cancel on that for now. Okay, so underneath the launch executable, we have launch executable advanced. Okay, where it supports time travel debugging. Okay, go ahead and click on that. And inside of this, we have a few options here. We have the executable, and this is going to be the absolute path to the binary that you want to launch. All right, very similar to the other one, launch executable. Okay, you can do the same thing here. You can hit browse, and same window pops open, and you can go ahead and browse to wherever the executable is located. And then you could pass some command line arguments to the executable. You can see here, one of the previous things I was looking at is related to the course I wrote, and just passing in some bogus command line arguments, just kind of see how things are working for that. One of the other options is you can give it a starting directory to say, hey, this is where excuse me, this is the directory where I would like this to be started with or started inside. And then underneath that, we have the target architecture. Okay, and it's probably set to auto detect by default, which is fine. A lot of times that is okay, and it's pretty good at detecting 32-bit versus 64-bit binaries. But there could be a certain point where you are forcibly saying x64, or you're forcibly going to say x86. And so later on in the series, I would like to do a demo of that, of when that might make sense to do one or the other. Auto detect is fine right now. Debug child processes. Okay, so if you know that this process will be or could be kicking off any other processes after it's initialized, then, and you want to debug them, you would go ahead and check this box. Okay, very, very rarely in my workflow anyway, do I need to worry about that. But this could be one of the things that could be very useful in your workflow, depending on what you're looking at and what you're trying to use WinDbg for. You would want to check that box to debug any child processes. And then record with time travel debugging. All right, time travel debugging is an amazing feature to have. And in fact, it's so powerful and so awesome that later on in the series, I'll have one workshop dedicated to just TTD, or time travel debugging. Okay, and also on that note, I won't be the one doing every part of this series. I'm going to bring in a guest with me coming up later in the series, another instructor for the 670 course. His name's Kevin Ott. So he's going to be helping out with this series as well. All right, so if you want to do time travel debugging, what even is TTD? So time travel debugging is kind of a way to travel through time specific to that process. So what happens is when you launch an executable and you record it with time travel debugging, the entire execution or life cycle, if you will, of that process is recorded. It's traced. Every single thing that it does is going to be watched and recorded, and some files are then created. There's like an index file, a .run file, and one other is just slipping my mind for a second there. But you'll have some of those files, and as long as you have those files, you will forever have the recorded lifetime or recorded events for that particular process. Now, here are some key points of when and use cases for that particular feature. Think about it from the world of an exploit developer or a vulnerability researcher. Having some previous backgrounds into those two fields, it's very annoying to have to relaunch a binary, reattach the debugger to it, set your breakpoints and stuff like that all over again, all to find this one magical moment where you're exploiting some kind of vulnerability, whether it be a buffer overflow or a heap overflow or whatever. And when you use TTD, you'll never miss that opportunity again, and you won't have to worry about reattaching, recreating that process all over again, trying to find everything like where you were before last time you're attached to a debugger, stuff like that. So you will always be able to go forward and backwards in that timeline of that process, long as it's been recorded with time travel debugging. Okay, so that's from an exploit dev perspective or VR perspective. One of the other awesome use cases for TTD for implant developers or malware developers. Okay, you're working on a certain feature or a certain capability rather for your implant, and you want to make sure that it's working as it should be, and that excuse me. All right. And that it's working as it should be with everything that you think you put into it. So you can record that execution and have that validation over and over again. Okay, so if you want to check that out, you can say, yes, let's go ahead and check record. And you'll see the menu change here to configured and record. And same kind of thing would happen. You can choose a location, you can hit browse. But this time, you're not choosing a binary that you want to launch. You're choosing where in the world you want the trace files to be stored after the recording has been finished. Okay, so that's all you're really choosing right here. Okay, and I never really messed around with record subset of execution, right? That's totally fine. And then you start record. Okay. All right, so we're not going to worry about that right now. Again, I'll have an entire section just for TTD type stuff. Okay, so moving on over, we have attach to process. Okay, when you click on attach to process, it does a process listing just like Task Manager and other things like that will give you. Okay, you can go through the motions here and just scroll around looking for all the processes that you might want to attach and gain some kind of introspection into that process to figure out what's going on. Okay, you could just go through manually. You can click on some of these to have them sorted by process name, by process ID, the session it's in, or whatever. You also have a way to go ahead and filter and search for something. So you can say SVC, and you'll see all the SVC host processes that are there. So filter is kind of nice. If you don't know the exact name, if you will, or there's just too much noise here, too many processes, and you don't want to scroll around forever and just type in a name and watch everything filter out. Okay, and then there's also a refresh button next to that. Excuse me. And the refresh button will refresh the process listing. And if you think there is a process that isn't being shown, you can go ahead and click down at the bottom the show processes from all users. Okay, so show processes from all users. I just clicked it, and you'll see we do have more results now. And we do see some that have the little shield icon. And what that is basically trying to tell you is these are elevated type of processes, and process like LSAS might be rather difficult to attach to from this current context because, one, we're not launching this as an administrator or anything like that. We just launched WinDbg as a basic user. Okay, and then same thing for when we're talking about launch executable, you could debug child processes. Again, that's if the process like conhost or whatever is going to be creating any kind of sub process or child process, and you want the ability to go ahead and debug those processes as well. Okay, and then architecture by default is on auto detect. Obviously, you have the option to change. Okay, and then down at the bottom right, you have the ability to go ahead and record with TTD. You have attach, and you have non-invasive attach. Okay, so a couple of options there for you. All right, and then the open dump file. A dump file is a particular file that gets created when a process crashes, when the system crashes and you have a BSOD, right, that blue screen of death kind of window, a dump is created, and a lot of times you'll see the .dmp file extension for that as a dump file. And WinDbg obviously is going to know how to treat that. And it'll go through the motions and process the dump file, allowing you to analyze a dump file and figure out what went wrong. Okay, in the instance of a process dump, even like a mini dump, you can try to figure out why a process crashed. Maybe there's a null pointer dereference, some kind of other access violation that happened that brought down the process. Okay, that little dump file is created, and then you can go ahead and browse to wherever it's located and open up the dump file. And then for a BSOD, okay, that's when the entire system goes down. You can go ahead and open up that dump file as well and try to figure out exactly what brought down the kernel. And the dump files aren't the only thing that you can open up here from this open dump file menu. You can see you can open up Windows binary image formats in the shape of .exes, .dlls, and sys for like drivers and stuff like that. Even some Linux things these days and Mac, right? Crazy. WinDbg's really trying to branch out. Okay, so you can browse to wherever that's located. And again, we see the target architecture being default to auto detect. Moving on down to the trace file. Okay, remember we're talking about TTD and time travel debugging. This is where you could go ahead and type in the absolute path, or even easier yet, just go ahead and browse to where one is located. Okay, so it doesn't have to be an actual dump file. Sorry, it's not going to be a dump file. You're looking for like a .run file, and that's given to you by default here on the filter on the right, .run. And then down at connect to remote debugger, it is possible to do remote debugging with this. I don't do it in user mode very often. I typically do kernel debugging, and we'll talk about that a little bit later today. And we'll also do a soft introduction into kernel debugging, how to set that up towards the end of the series as well. Inside of attach to kernel, you have a couple of options of how to do kernel debugging, how to get to kernel debugging. We have not .NET, network debugging, debugger.com with the pipes, name pipes, and local debugging specific to like this VM or your Windows host or whatever you're using right now for WinDbg. What I like to do is I love doing network debugging, and when I go through later in the series of how to set this up, we'll do a proper introduction of how to set up a target system for remote kernel debugging using KDNet. There are plenty of other utilities out there that help you get the remote connection set up and established. I'm not trying to say one is better than the other or anything like that. They all have their purposes. I just like using KDNet. It's one of the things that Microsoft provides. All right, so we'll get into that towards the end of the series. We'll do a soft introduction into kernel debugging, just get it oriented inside the kernel, how to break into a, excuse me, how to break into a user mode process to get into its context, how to get back out into system context, and stuff like that. Okay, and then some of these are stuff we don't really care about whole too much. Saving workspace, excuse me, in theory, gives you the ability to save some of the configurations for what you have set up. My personal experience with saving a workspace, it hasn't been 100% every single time. And it'd be nice if that would be a little bit more reliable, at least from my experience anyway. Source files, exactly what they sound like, an actual source code file, like .cpp for C++, C for just pure C, and of course header files. Okay. And open a script or not. Okay. So scripting, you can use some JavaScript to create some scripts to help automate the workflow of debugging. And then skipping down to the settings. Okay, we have some general settings, and probably the most important one is setting the theme. By default, I think it's on light, and that's way too bright. And then dark is probably everybody's favorite. It's definitely my favorite to have. And then you can change the font sizes and even the font family for whatever you need for your preferences. And then for debug settings, okay, you have a few options inside of here. You can have a default source path. Okay, so that's where it's going to look by default every time for source code files. You also have a default symbol path. Okay, symbols, debug symbols are very handy when you're trying to understand what's what about a process, especially for kernel debugging. If you don't have symbols and kernel symbols and stuff like that, it is rather challenging to do some kernel debugging without proper symbols. I would almost say just forget about it. But in any case, you might see something like this already in there, which is totally fine. Serve star, serve splat, or whatever. You can actually go ahead and browse to a place. Okay, so a little bit later in the series, I'll show you how you can download symbols from the command line, how you can force the downloading of symbols for all executables, all DLLs, stuff like that in the System32 folder. That way it goes out to Microsoft's symbol server and tries to pull down all the symbols for those binaries and those versions that you have on your system. Okay, so having symbols are definitely very critical and very important to have, especially if you're dealing with Windows processes or Windows DLLs. Now, if you're looking at malware, obviously you're probably not going to have symbols. All right, be nice, but it's probably not going to happen. When you're compiling your own binaries, you then have the option to go ahead and compile that binary with symbols, with like a PDB file, to go ahead and say, hey, when I start to debug this program, I want you to go ahead and look here, whatever folder you would like, and pull in this PDB file because it has symbols. That would make debugging a whole lot easier for this particular process. Okay, and if you ever want to add multiple line items here, you can just hit enter or return and come down on a new line, and all those should save for you. Okay, it's to me, those are the two most important fields there. Events and exceptions, not going to go too deep into this one. These are just different events that or exceptions that you can kind of change to say, hey, I don't want this to be handled, or I do want this to be handled. Ignore this, don't ignore that, or whatever. So you can change some of these and look at some of these stuff on your own time. Command window, excuse me. Command window, source window, just some options there. Disassembly window. Excuse me. And disassembly window, basically just saying, hey, how many how many bytes do we want to show here, and you can set to 15 or whatever number you would like, and we can show you what that looks like inside the disassembly window when we pull it up. And kernel debugging events, I really don't mess around with this. Or sorry, kernel debugging settings, I really don't mess around with this really at all. But I'm sure somebody has for a very particular need. Okay. All right. So that pretty much takes care of the file, right? So we have these other pieces here that are more specific to when you have either when you attached to a process or when you launched a process, which is basically going to be a child of WinDbg. Okay. So you have your home. A lot of this stuff is already grayed out. So there's no way you're going to click through any of this stuff. And that's because there's nothing to do yet. We haven't spun up a process. We haven't attached to a process or anything like that. So all that would be great. All this will come alive with colors once we attach to a process. And we're going to pick Notepad here in just a second. I love picking on Notepad. Okay. And then view, right? This is how you get some of these other panes or these windows to show up. Okay. So for example, if I didn't have the disassembly or the memory windows open, you go to view. Okay. And you can click on memory. You can click on disassembly and it'll bring those back up for you. And you can go ahead and adjust these however you want. So you can click on one and you'll know when one pane is active when it's been blue, right? When the title bar here is blue. Okay, you see the command window and memory window are gray, right? They're not active. So you can click on the bar there and it starts to float around. And when you're moving it, you'll see some other things pop up. And we can say, all right, well, if I want to put you over here, maybe I want to put you here, and this is a split window. All right, I want this split horizontally or vertically on the right side or left side split, bottom split, top split, or whatever, or basically just kind of like take over and have like a tabbed view of sorts. Okay, so those are some options for how you want your layout to be. But for me, I'm just going to keep it over there. And then once you have your layout the way that you like it, and it might take you a little bit to understand with how you want to use WinDbg. How do you want to use it for malware analysis, exploit development, VR type stuff, general debugging for your software development needs, or trying to debug your implants as you make them. You might want some windows up persistently and some to be hidden and kind of out of the way. Whereas it's not closed, it's just kind of out of the way. And what do I mean by that? On the far left-hand side, you see one little thing, at least on my window, it says registers. Okay, so if I click on registers, that pane will open, and you'll notice the little thumbtack here is set to auto hide, meaning it's not going to be a persistent view inside of my layout. Okay, so if you wanted it to be a persistent view, you go ahead and pin it, all right, and then you can move around wherever you would like it to be. Okay, so I'm actually going to go ahead and hide that back and keep that over there on the left. Okay, so you can go and click through some of these different windows to view them or whatnot. One thing that is kind of cool is the notes, right? It's like a little scratch pad of sorts of when you go through the motions of using WinDbg and you're like, hey, I actually need to keep track of this particular address or this particular structure type, this field member or whatever kind of notes you have as you go through the motions of debugging a program. You can type in wherever you need here in like a scratch pad area. And so I use the notes window all the time when I'm doing some debugging. Okay, we'll go ahead and crush that one for now. Modules, command browser, and different layouts. And then you can reset the windows if you would like. And if you want to choose some different colors for the accent, you can do that as well. Okay, breakpoints. There's nothing to do here for breakpoints. We'll come back to this later when we actually attach to something. Time travel specific to TTD, time travel debugging. Okay, model, I'm not going to be worrying about that in this series. Scripting, probably not going to touch that in this series. Source code files, the memory window, choosing like the size, how you want the format to be. Do you want it to be all hex bytes, treated as unsigned or signed or what have you? How do you want the text to be displayed? Okay, so that's going to be this area here. Do you want all these bytes in the middle? Right, so when you start to look at something, do you want all these bytes here to be treated as ASCII, the ASCII representation over here? Okay, so that's what's going to try and happen there. Okay, and you can also choose a size. Basically, it's at byte right now, but you can totally choose how you want that to be, going like 8 wide, 4 wide as float, or 4 wide as an integer. So on and so forth. But I tend, just personal preference, I just like the bite sized. All right. And then the command window. One of my favorite things inside the command window is the ability to highlight and unhighlight memory addresses. Again, this will make a whole lot more sense. You'll see this come to life when we jump into notepad process and we launch that off. Okay. All right. So real quick, does anybody have any questions before we go ahead and jump into notepad? Everybody doing good? All right, sweet, awesome. All right, so how in the world do we get started, right? So remember before in the file menu, we have a couple of different ways. Oh, I see someone got a hand raised. Do you have a question? Feel free to type it out if you got a question. Okay, yep, see the question there. Time travel debugging also resolve all addresses and values. It's going to record everything, 100%. Yep, all of it. Threads, doesn't matter how many threads and stuff like that were kicked off during the lifetime of that process. Every single thing that the process does is going to be recorded and traced. All right, that way you can go through later and say, I actually want to look into this thread at this address, see what it was doing at this particular instruction. I want to see when it was writing a file to disk. I want to see when it was reading a file from disk or making a socket connection or a web request or whatever. But yes, all those addresses, all that stuff will be there forever inside that trace file. Cool. Awesome. Even if the binary is packed. Well, so the execution will absolutely be recorded. And that's just the beauty of TTD. And then obviously as a packed binary, a packed piece of malware eventually will be unpacking itself, right? And that is the ripe time to go ahead and extract from memory the unpacked sample, the unpacked piece of malware. So I've not specifically tried that scenario to do a TTD recording of a packed binary, but my assumption and my hunch is yes, even if it's packed, it will be recorded. Okay, then you should be able to go through and over again, see how it's doing itself, unpacking stuff like that, and anything else that little piece of malware or whatever. Even if you're trying to do your own custom packing, which I've done a couple of times, it's it's a great way to go ahead and look at what you're doing for over and over and over again, as long as you have those trace files. Yeah, good question. That's a solid question. Cool. Looks like we don't have any more questions popping open at the moment. Awesome. All right, so let's go ahead and let's pick on my favorite guinea pig. That's Notepad. So we're going to go ahead and launch that as an executable here. We're not going to worry about the advanced for TTD. Again, I'm going to have a dedicated 2-hour workshop just for TTD, and hope to bring on my buddy Kevin to help out with that one. All right, so you probably won't have recent, which is totally fine and expected. Okay, so one of the things that you could do is type in the folder path up here where Notepad is. Okay, it's C Windows. Notepad is actually located in a few areas for some reason, don't know why. But one of the locations where Notepad is under C Windows. So once you're in the right folder, you can go ahead and in the file name, start typing in Notepad or whatever is of interest. And then all you got to do is just click open. Okay, so now more things have finally been brought to life. Okay, so under the home, right, we now have some things that have been colorized. They're no longer at a grayscale, like black and white kind of color scheme. We can see that we now have the option to like restart. We can stop debugging, and we have the option to detach. Okay, so restart, exactly what it sounds like it's going to do. Go ahead and restart this instance of Notepad and have it initialized and loaded into memory all over again. Stop debugging is exactly that. It's going to stop debugging, and it's going to close this instance of Notepad. All right, so detach, basically we're going to say, hey, Notepad, I know you're running, but I'm no longer interested in debugging you. So I'm going to go ahead and detach myself from you. I'm going to let you run. All right, so be free. All right, we're setting Notepad free, and it can go ahead and go about its merry way and take notes. Okay. To the right of those options, you have settings, which gets you back to where we've seen before under file debug settings, and then source or assembly. Okay, so source and assembly. Excuse me. This cough is getting the best of me today. This is basically how WinDbg is going to step through instructions. At the assembly level, meaning one instruction at a time. So if you have your disassembly window open somewhere, you should see some instructions have been loaded and addresses and stuff like that. And assembly, stepping through by assembly line, says, hey, we're going to execute this in 3. And then we'll go ahead and execute the jump, and then we'll go ahead and do this add, and then the ret, so on and so forth. Okay, it's going to go one instruction at a time. The source, something we can't do for this because we don't have source code access to Notepad. The source is kind of nice when you're developing your own software and you want to step through one line of source code at a time, okay, which could be like 30 instructions for one line of source code, right? Just making something up, but it could be that way. Okay, so that has gotten me a time or two, and when I wasn't really paying attention to how I was stepping through instructions, it was on source. And I went and tried to execute one instruction, and it just skipped ahead like 30 instructions to execute one line of source code in my C++ program, and completely missed a bunch of things. All right. All right. On the left-hand side, you have the pause button over there, or the break. All right, the break. This is when you want the execution to pause, or you want, let's say you're running some kind of script, or you're trying to download some symbols from Microsoft symbol server, and it's just taking forever, as it does sometimes. And you say, I don't have the patience anymore. So you go ahead and break, and you say, be done. Okay. So that's one of the use cases for using break, or the pause. Go. All right. This is where you say, hey, you know what? Let's go. Go ahead and keep running through all the instructions without us manually jumping into here and doing anything. Okay, so what I would like for you to do, if you have Notepad already here, just for demonstration purposes, just hit go, right? Hit the big play button. All right, hit go. And it says the debuggy is running. It says busy, right? So inside of the command window at the command bar, you can't do anything, right? It's busy. And you probably have seen the Notepad window open up, okay? And it's completely usable. You can type in all this stuff, whatever, all this gibberish, and it's just like Notepad, right? Notepad probably is none the wiser that was launched by WinDbg in that it's been attached to, and that we're debugging it. Okay, it's probably not very smart that way. Hey, there are plenty of malware samples and whatnot where they definitely want to know if a debugger is attached to them or not, because maybe they're going to operate a different way, they're going to behave a different way, or they're going to do something else to try and thwart being debugged. Okay, in any case, so you're at this state where the debuggy is running, or it's doing something, it's in a busy mode, and you're like, well, crap, maybe you're waiting for some debug event to happen, or some exception or whatever to happen inside the process where it kicks back to the debugger, where you have control again inside the debugger, right? Because right now we don't have much control over Notepad while it's running. There are a few things that we can do. We can stop debugging and we can detach. Okay, that's about it. To gain that full control back, we'd have to basically stop Notepad from executing where it is right now. So one of the things that we can do, and probably the most important thing to do, is hit that pause button. All right, boom. Execution has now stopped. Okay, so with, excuse me, with the execution now being paused, or stopped, I guess, is how they kind of say it. Now we have the ability to go through and look at different addresses in memory. Okay, so if I happen to know some other address, like, I'm just going to copy this one, just a demo. Of course, pulling out symbols from the symbol server. How about that? See how sometimes it takes a while? Okay, there it finally came. Okay, so now I can go through and look at different areas in process memory, all that stuff. We can see how things are disassembled. I can come out here in the main memory window, type in that same address, and see like the ASCII representation of all these bytes, these hex bytes and stuff like that, which is really cool. So we see the MZ or the MZ header, the 4D5A, basically saying that we are at the start of an executable image inside memory. So a question out there in Zoom is, how long does a debug typically take? That is that's a pretty open-ended question there. And what In what aspect? Debug as far as debugging a piece of ransomware, looking at a kernel driver, looking at a piece of software that you wrote by chance. So good question, just not sure what kind of perspective going for there. Because debugging can take a very, very long time depending on what you're looking at. Especially if you have or don't have symbols. Okay, looking at a piece of malware or whatever that's highly sophisticated, that has done a lot of anti-debugging, anti-obfuscation, or obfuscation techniques and stuff like that. It could take a while. Also, I could say that depending on your comfort level with a debugger, doesn't have to be WinDbg. We're just picking this one because it's my favorite debugger for Windows kernel. Okay, there are plenty of other debuggers out there. My all-time favorite user mode debuggers, x64 debug, hands down, one of the best user mode debuggers. But anytime you're trying to get into the kernel and stuff like that, WinDbg is my hero. So yeah, debugging can take a long time. I can't give you a definitive answer to say debugging, whatever is only going to take 30 minutes. It really depends on what you're trying to look at too. Maybe one of the use cases for you to use a debugger would be you're writing some kind of application, some kind of software program or whatever, and you are trying to find some kind of little logic bug or something like that, some kind of issue, and you're trying to track it down, and you kind of know where to look when you're debugging it. So you kind of jump straight there, right? So it might not take too long for you to do some debugging for that specific issue. But if you're going through the motions of looking at a piece of like malware, for example, and you're trying to get a much better understanding of what it's doing, it's probably going to take you just a little bit longer if you're trying to understand every tiny little thing that it's doing. Okay, so debugging can take a while, depending on what your goals are. So hopefully it answers the question. If not, feel free to ask another one there as a follow-up. All right, cool. So moving along here. So back into Notepad, we basically froze, right? We froze Notepad. And we're at a point right now with some random instruction. And whatever Notepad was doing at that moment in time, we basically just said, you're done, right? You're done for right now. I'm going to interrupt you. I'm now in control. And I'm now going to be able to look at everything inside. Okay, so one of the things that could be of interest for you, if you're coming from the perspective of a malware analyst or anything like that, could be to look at some of the loaded DLLs that are there. Maybe you're looking at some DLLs that have been loaded manually, meaning there's a DLL in memory that has been loaded, but there isn't a DLL on disk. Okay, so there's reflective loading or manual loading of DLLs where you're trying to avoid being on disk, and by doing so, you kind of really help your chances, you increase your chances of not being caught. You're increasing your dwell time, if you will, on target by not dropping things to disk. All right, so you go through the motions and you manually load a DLL. But it could be of interest to look for other DLLs that have been loaded by a process as well, because maybe you're interested in some kind of a function, right? The whole purpose of a DLL is to share code, right? It's a great way to share code with other developers and stuff like that. I mean, that's why Windows has given us all these DLLs that we can use and we can link to call functions from them, right? Like kernel 32 and kernel base and ntdll, just to name a few, are very, very robust, and they offer and they export thousands of functions for us to use to create malware, to create implants, and to do all kinds of different interactions with users, files on disk, registry, sockets, all types of stuff. Okay, so if you're trying to figure out what type or what specific function has been exported by a DLL, and maybe you want to set like a breakpoint on that particular function. Okay, one of the things that you could do is inside the command bar in the window down there at the bottom, you can type lm. All right, so lm, what it's doing behind the scenes is it's getting us a list of all of the DLLs that Notepad has loaded at this moment in time. All right, so if we give execution and control back over to Notepad, and more DLLs have been loaded, then we could go ahead, you could pause and run lm again, and maybe you see more. Maybe you see less. Maybe some DLLs have been loaded, which can happen and does happen, right? A DLL doesn't have to be there forever. Excuse me. Okay, so we see some symbols have been obtained, some PDB symbols, some have been deferred, meaning that a request hasn't gone off yet to the symbol server to go ahead and pull down the PDB file for this particular DLL or for this particular executable. Okay, so at least on my system right now, we pulled down the symbols for Notepad itself, some random DLL win types, and ntdll. Okay, and then the rest of these are deferred because we don't need those symbols just yet. Okay, so one thing that's kind of nice about WinDbg and about the output inside the command window is the blue hyperlinks. Okay, basically just like website links and stuff like that you might see in the phishing email. They're clickable. Okay, you can go through and click on some of these to get more details about them. All right, but before we do that just yet, I want to explain some of the output here and what some of these fields mean. Okay, so right after you do the LM, you have a couple of headers. We have start, which is basically the starting address where this module is located. Okay, and then we have end. This is the end, all right, where this executable image, the last byte, if you will, should be located. And everything in between start and end is that entire executable image. And if you subtract these two together, or if you subtract these two, you would have the size. Okay. And excuse me. And it might be a little bit more bloated because you have to deal with a lot more pages of memory and stuff like that. But it's roughly the whole size of the image. If you wanted to, you could go ahead and double click on one of these addresses, just picking Notepad, for example. And if you do a double right click, it's basically a shortcut copy paste to go ahead and come from the command window output up at the top, and it shoves it down at the bottom. Okay, it's kind of nice little shortcut, especially when you're dealing with the memory address. Then you don't have to worry about doing the whole Control C and then come down here and click inside of here and do Control V. Okay, and then the other thing that's kind of cool, and again, this is my favorite piece about the command window at the top, is when you come up here to command, right, the command file menu, I mentioned before the highlight, unhighlight. So let me go through and let's double click the start address for Notepad. And then under the command, go ahead and click on highlight as an ugly color. So it'll go ahead and pick some color. Mine is this nasty mustard yellow. Let's see if I can get a different color somewhere. We'll click on NTDLL. We'll highlight that one. We'll pick a few more too, just because why not? And let's look for Kernel base. Okay. All right, cool. We got 3 different colors up here. Awesome. Now, what's really sweet about this is every time the command window sees these addresses, it'll go ahead and make sure that it's been highlighted this particular color. Okay. And then on the right-hand side in the scroll bar, we can see all the different times that those addresses have been seen before. Okay. We see that previously when Notepad was first being initialized. We see the module load events of different modules that have been loaded. We see those values there. Okay, the other thing that's kind of cool about this is I'm going to go ahead and take this address, put it in my clipboard, and let's bring up the little scratch pad again. Okay, so notes. And we'll just paste that address there. So not only does it highlight the address in the command output area, but also in your notes. So whenever you're going through the motions and saying, hey, this particular address is important for whatever reason, you can come up here in the notes and add it there. And maybe this is just the base address of Notepad. Okay, maybe that could be a note or something like that that you would want to take down. Like I said before, I use this particular feature a lot, especially if I'm dealing with some kind of undocumented type of structure, and trying to understand and keep track of, let's say, the base address for a structure or what have you. I can come in and find the base address or whatever for that structure, highlight it, and put it up here and make a little note, say, hey, this address is the base address for this structure. Now I know I can come in later and access that structure in the various fields of that structure with pretty much with ease. Okay. All right. So anyway, how do people even find undocumented structures? Well, it's not easy, but one of the great things about undocumented structures and APIs is that thankfully there are so many other researchers that have been out there, like Yarden, Pavel, quite a few others who have done an amazing job at documenting some of this stuff. And going through that, they're also trying to take advantage, I would imagine, take advantage of symbols too. So when you get those symbols from Microsoft about like the kernel, driver, or DLL, or whatever, a lot of times information about structures is in there too. Whether or not it's documented on MSDN is a different question. All right, then go through the motions, and they do. I forget who I was talking to the other day. They have some kind of fancy extractor script that they'll run through PDB files to extract like type information and stuff like that around some of the symbols inside of one of those PDB files, which is super awesome to do. But yeah, you kind of have to know what you're looking for, where things are being located. And even if a structure is undocumented from MSDN documentation, let's say, for example, it at least gives you the type, the structure type for, let's say, a parameter. Okay, there's a parameter. You need to pass a pointer to this type of structure, but they don't give you, they meaning MSDN, they don't give you any kind of information about the structure. It's supposed to treat it as opaque, meaning don't touch it. At least you have the structure type that you might have a symbol for. And there are plenty of researchers out there that have taken their time to do reversing, and some of the documentation, write blog posts about it. Yeah, Virgilius is an awesome project. The Virgilius has done an awesome job at documenting a lot of that stuff, but I do know there are still some that Virgilius doesn't have. There's also React OS. So the React OS project is also really good at checking out some of the undocumented structures and undocumented APIs. And how do they even reverse it? Experience. I would say that'd be the biggest piece right there. Experience with just Windows in general, Windows internals, knowing kind of how things are laid out in memory, knowing how processes work, threads work, how things are initialized, all that type of stuff can really come into play. And again, I do know there are some people out there that have a crazy, crazy amount of header files, even old ancient header files that are no longer publicly available anymore, that can really come to play for understanding some of these structures and stuff. Yeah, reversing it is basically just coming with experience and time, being familiar with internals. Could we leverage WinDbg to compare different versions of binary software to debug and eventually take advantage of a vulnerability? You thinking like patch diffing? Because I think if you're thinking of patch diffing, my take is I don't think WinDbg is directly geared for patch diffing. Not saying that it couldn't be done, but I don't think that's a primary purpose. And I'm not sure. I've never tried to do that with WinDbg. I don't see how patch diffing would be possible inside of WinDbg unless you wrote some kind of script or a custom module, like a specific extension to load in there. But yeah, I don't think it's geared for that. Would be kind of cool. But yeah, I don't think so. Like bindiff obviously is like the de facto standard for that one there. I just don't see WinDbg. I don't know anybody who uses it that way. Let's say that. But yeah, I'm not really sure on that one. I've personally have never tried to use WinDbg that way. There could be some crazy things that you could do to kind of make it behave that way. But I don't think you would really get what you're looking for there just by using WinDbg. That's a solid question, though. Good question. All right. Cool. Good questions. Keep them coming. All right. So back inside the command window. All right. At this paused state, we're looking at some different things that have been highlighted, different addresses and stuff like that. And I mentioned before that all of these blue things over here are basically like hyperlinks. Okay, so you can go through and just click on one. Let's just click on Notepad. All right, click on Notepad. And whenever you do this, it'll go ahead and show you the command that it ran behind the scenes. And it doesn't make it look pretty by any stretch. But we see here the command, the base command is lm, which is just listing modules with some extra arguments like uppercase D, V, M, and Notepad. All right. So basically trying to do a filter on the Notepad module, but all squished up together. Okay. while I'm thinking about it, WinDbg has a pretty decent help menu. So you can type in a .hh and open up the help menu. And you can also give .hh like the name of a command or whatever, like lm, for example. Or since we're already here, you type in a keyword and type in lm and just hit enter. And it'll take that first hit there. And it tells you a little bit about the command, what it should be used for, to list loaded modules. And it gives you some of the various options that you could pass to it. Okay, so we saw the uppercase D, and you're like, well, what in the world is that? And that displays output using the debugger markup language to make things kind of clickable. Okay, you can see some of the other options there. V is very typical of verbose, increasing verbosity, stuff like that. We have ones specific for kernel mode and user mode only. Going through the motions here. You have SM, which is kind of cool because by default, the LM output, I'll just run LM again. Everything is situated and organized by start address. Oops. Okay, if you do LM SM to do a module listing and sort by module name, everything then is in alphabetical order. So if you're looking for something specific like kernel base or RPC CRT, you can very quickly go ahead and jump to where it is alphabetically. All right, so back up here. Okay, and then some of the other options there, we can see N for displaying the image name, and P for the mapped image name, T for timestamps. Then you can optionally give it an address or a pattern with two versions of M, uppercase and lowercase. Okay, and then some examples. This is also what's super cool about some of the help menu items here is the fact that the examples are pretty good. They give you not only an example of just the command, but some of the output that you should expect to see by running the command. Okay, so I think that's pretty sweet. All right, go ahead and crush that window. Again, to get back to that one, there's a couple ways to do that, but my favorite way is just down here with the .hh. All right, so looking at all these modules here, we were looking at Notepad because I asked you to go ahead and click on Notepad, and not only does it show us the start and ending address again, but it gives us the module name and also the full path for the PDB file for this version of this binary. If you've ever done anything with debugging before, whether it's Notepad or it's WinDbg or not, you'll know that there could be several different versions of a binary like NTDLL. And so there could be all different kinds of PDB files for NTDLLs. All right, so it gives you the image path, the image name, and then we have some clickable items here with the fancy debugger markup language or DML. And then just some basic information about the image itself. Okay, the file type, the file date, kind of, it's nulled out. The company name, product name, the internal name of it, so on and so forth. You get the idea. What could be of interest, though, for debugging in general is, well, really a couple of things. You can look at functions, or you can look at like data for some other symbols that might be present inside of an executable or inside of a DLL. So if you click on functions, all right, let's click on functions. All right, you can see the command that it ran for you behind the scenes, as if it was like magic. We have X. All right, X. You're like, well, what the heck is X? So you could do .hh X. Okay, and it's a way to, there we go. Now it actually went. It's a way to go ahead and examine something, an address or whatever, specific for symbols. Okay, and it gives you syntax as well for how you could use this. All right, so the base command X and then some options and then the name of a module like Notepad or the name of a DLL like NTDLL or kernel base. And then we have a delimiter, the exclamation mark of the bang, and then the name of the symbol. And then we have a wildcard search as well, which really comes in handy when you really don't know what module exports or holds a particular symbol. And that symbol could be the name of a function or a structure type when it comes to like parsing PE headers, stuff like that. Doing a wildcard search can really come in handy and let WinDbg go through the motions and say, I know all the modules that have been loaded inside this process. Let me go through all of them, see what I can find for you. And I'll even go out to the symbol server and pull down the PDBs for all these too and see what I can find. So you got to be careful though when you're using the wildcard for something like this. And that is the fact that it does go out and try to pull down symbols. That can take a while. All right, depending on the symbol server that day being good or not. I know there's a lot of jokes about Microsoft symbol servers not being up all the time. But in any case, we can talk later about how to grab symbols from like an offline machine and to make like a manifest file to then take that manifest file, give it to another system, let's say that has internet access, because maybe you're doing some kind of sensitive analysis on a system's air-gapped, which you typically will have air-gapped systems when you're looking at malware, because you don't want it to be able to call off into the true internet or whatever. And so it's like air-gapped in a sense, but still could be nice to have symbols from an air-gapped system. So we'll take a look at how to do that. Okay, so there's the X command. You can see some of the parameters there. And one thing that's kind of interesting to me is how WinDbg wants some of these options. If you remember looking at LM, all right, let's just go back and look at LM. The options were just right next to LM, and they don't want a / or attack or anything like that. But if we look at X, all right, we want / okay, for this, which is kind of crazy. I don't, maybe it's just me, but I find that to be a little bit crazy. And maybe it's just because of the way the X command is created, how it expects some of the arguments to come through and stuff like that. So, hey, I get it. All right. So, again, there are some examples of how to use this command. We see the X, some module, the delimiter, like the bang, and then the wildcard, right? On either side of the word spin. All right. So basically it says, hey, look inside of my module and give me everything. Give me everything that contains spin somewhere inside. Okay, and then some more examples, getting a little bit more fancy here, doing like a for loop, pretty much, for those familiar with C. It's very similar kind of syntax-ish, but the logic's still the same. Okay, go ahead and crush that. All right, so inside Notepad, when we clicked on the functions, we had a few things inside of it. Abort, write file, exit, alert box, so on and so forth. Okay. And we see we have the option to filter on other functions as well. You could just choose M, for example, and we get a lot more back, right? A lot more there. Now, you could go through the motions and just keep on clicking to say, hey, you know what? I'm trying to find a function that has the word create in it or whatever. So you really wouldn't want to like just click on C and browse in the C's. Very similar to the help that we just looked at. You would do that wildcard search. Okay. And so what that could look like, again, very similar to how it was doing spin. You can just type in create and then send it away. Okay. So we get a few hits, several hits that have create somewhere in the name of the symbol or the name of the function. Okay. So we got create edit control, create dib section, create a solid brush, blah, 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 some other create functions. Okay. So you could go through the motions and try to figure out where create is, or any kind of create function is located, or even a symbol name is located inside of Notepad. But if, this is probably going to be crazy, if we're not sure where exactly we want to look, we could do the wildcard for the module and just say, look through everything, find me all the things, all the modules that have create. So we're just going to get crazy and run that one. Just kind of show you what it does. And down at the bottom left, you can see that it's making all those queries out to the symbol server, pulling down all those additional PDBs because I told it to. I said, I don't know the module. You find it. Like, you go find the module and find me all the things with create inside of it. Okay. Probably not the best thing to do. As you can see, it takes quite some time. And there are a ton of results that are coming back. Okay. Now, depending on exactly what you're looking at, hopefully you could be a little bit more precise with your searching. And remember, I told you before, you have to use the wildcards. You have to use those wildcards just a little bit sparingly to avoid instances like this. So we're still pulling in symbols, going to Ole 32. So we're making it through very slowly. Let's see what happens if I just go ahead and say pause and break. Oh boy. There we go. It took a while. All right, but we told it to quit. All right, so that, who knows how much longer that was going to take to go forward. But thankfully, the break command was a nice way to go ahead and quit downloading all that stuff. But what we have, tons of results for all the modules that it could find in that amount of time that have a function name that has create in it, or even a symbol name like a structure or whatever that has create inside of it. Again, please don't be that crazy with the wildcards. Try to be a little bit more precise when you're using those wildcards to avoid instances like that. Excuse me one second. All right, cool. So we've gone all this way and we haven't even stepped through any instructions or anything like that. So let's go ahead and talk about that now, shall we? Okay, so wherever we paused Notepad, right? We totally interrupted whatever it was doing, taking notes for somebody. And we said, hey, pause. All right. And then everything came back to us inside the debugger. We have full control now. And then all the registers have been loaded with values. Okay, so you can take a look at the registers pane. And you'll see here, there are some values that have red inside of them. So one thing that's really cool is whenever something changes, WinDbg does a really good job at trying to visually grab your attention to that change. And it does so by changing the color of the font, like red, for example. Okay, so not only does it do it there inside the registers pane, but a lot of times you can see that inside of a memory window as well. Now, specifically for the memory window, what I like most about that is, let's say, for example, I know that a piece of malware or whatever is trying to decrypt some shell code or decrypt something, anything, a config file, internal configs, or whatever. It's trying to decrypt something, and it's going to do so in a buffer. Okay, and you've done your debugging efforts up to that point, and you know the address of the buffer. Okay, so one of the things that you could do is you could take the address of that buffer and put it in here inside the memory window. And when the decryption happens or whatever, all the bytes that are changed or whatever that will come in here will be red to let you know, hey, this has changed from the last time we saw this page of memory or these bytes on this page of memory, to really grab your attention to say, hey, look, something happened over here. Excuse me. All right, so that's really cool of WinDbg to do that for us and to grab our attention when things change. But that's just one use case of how I like, of how I like looking at like a buffer example or page of memory or whatever inside the memory window and seeing all those bytes change to red when something new is there. Okay, so back into registers real quick. Okay, if you're not familiar with registers, well, I really don't want to turn this into an intro into CPU registers or anything like that, or intro into assembly. I think that'd be a cool series to have, an intro to assembly. But it's really awesome to take a look at the various registers and values that these have, specific to function calls. Okay, so there are a number of different calling conventions for various functions. And we'll take a look at some of the different calling conventions and how to find the various parameters that are being passed into function calls, so you can take a look at them and try to see what the values are, try to make sense of what's happening behind the scenes for any particular parameter. That way you can kind of have a better understanding of what the arguments are, what the values are that are being passed into a function call. All right, so the registers up here are not all of the registers. There are plenty more behind the scenes that's not showing you. All right, which is fine. Okay, we're not going to worry about those right now, but there are plenty of other registers. These are basically probably the most important ones, if you will, that's showing you right now. So we have racks, the RAX register, which is a very useful register. Yeah, excuse me. One of the primary purposes of racks is to hold the return value from a function. All right, so whenever a function is going to return something like a number, a string, or whatever, a lot of times you'll see racks being used to hold that value. So whoever called that function can go ahead and pull it. All right, then we have some other registers that are of interest. Probably the two most important ones be RIP, the instruction pointer, and RSP, which is the stack pointer, saying, hey, these are the current addresses, and this is the current instruction that we're pointing to, we're about to execute next. Excuse me one second. All right. And then below that, we have this thing called e-flags. All right. E-flags are basically just like extended flags. And inside of that, we see that this field here, this value, is broken down to all these sub flags. All right. So feel free to look some of these up on your own time after the session is over. But we have a few flags that could be of interest as you go through debugging things, like maybe looking at malware or whatever. So we have like the 0 flag, ZF. We have a trap flag. So for example, the trap flag, internally, that's the magic that allows like debuggers like WinDbg to kind of work. All right, the trap flag. When that is set, meaning it has 1, right? So you're going to have 1 or 0. So it's going to be set to 1 or cleared to 0. Basically, what happens is when it's set, that when a trap flag is set, it'll go ahead and allow an instruction to execute. Like for example, this pop R10, allow that to go ahead and execute. And we're not going to get any further, right? We're going to be interrupted. And we're going to stop right here. And the debugger will present you like this window again, with full control to go ahead and decide what to do next. Like we're trapping some of those events. And WinDbg is actually doing a lot more behind the scenes to make it so magical of an experience for you that... Oh, excuse me. That's trying to make it just smooth and seamless for you. So there are a lot of things that's happening behind the scenes. One of them is automatically going and setting and clearing the trap flag automatically every time you're stepping through instructions. Okay. All right, so that's registers and stuff like that. Last error value and last status value. From a developer perspective, these can be really, really, really awesome to have insight into. Last error value or last status value, when functions are going through the motions, trying to do what they do and carry out some kind of function, like creating a process, for example. It could be possible that create a process fails for whatever reason, and internally it's going to set an error value. All right, it's going to set the last error to something, could be like 5 for an access violation or whatever. And you can see this change after every function call, after every Win32 API call. Some of the stuff can change. From the dev side of the house, there's a function call that you can invoke called get last error that will pretty much come into this kind of thing and say, I want to actually grab the last error value that was set by the most immediate, by the most immediate function call. Okay, so a little bit later, I'll show you some source code into what I mean. So we'll make a very small program, maybe in part 2, hopefully next month. We'll make a very small program in C and can show you how some of that stuff works. Okay. All right. So looking at some of those registers, looking at where we are right now, and now let's actually execute some instructions. Multiple ways to do this. You can go ahead and go up to the top, and you can choose step out, step into, or step over. What do those even mean? Okay, so step out. Step out basically is going to say, excuse me, it's going to say, all right, we're inside of some function right now. Don't know what function it is. Don't care. I don't want to be inside this function anymore. Let's go ahead and get out of it. So let's go ahead and execute all the instructions, all the remaining instructions inside this function until we're about to be out of here and get back to the parent function or whoever called us. Okay, so that's basically what step out is all about. Step into. Okay, so this is where you're about to, let's see. Trying to find a function just to show you. You don't have to follow along on this one. Wow, there's way too many in here. Okay, never mind. So step into basically says, hey, if this function here inside shell 32, the create bitmap from icon, was about to be called, and we want to actually go into this function and see what some of the instructions are doing inside there, we would choose step into to follow execution, follow the instructions into that function. All right, because maybe there's something of interest we want to see there. Okay, so that's what step into is. Step over is basically where I want you to go ahead and execute a single instruction, even if that single instruction steps over a function call. Okay, so again, if we're about to make a call to create bitmap from icon, and I don't care about what it's doing internally, why waste time debugging through that and single stepping through that, all that jazz? Just go ahead and hit step over and be done with it. All right. So those are just a few things, right? And if you're hovering over, a lot of times WinDbg is very good at showing you some of the keyboard combinations or hotkeys, if you will, what you can use. So Shift F11, step out, come on, step into F11 or F8, and then step over is F10. Now we played around with Go, that's F5, and then you can also hold down here, go unhandled exception or go handled exception. Okay, there's also commands that you can type in here that basically have the same effect as clicking those buttons up at the top. Okay, so when we hit go before, it's basically coming in here and hitting G. All right, so we're back to a running state. All right, but I want to be there. All right, so now we've broken again, and now we go ahead and enter in whatever command we would like to see. Okay, R, we showed you registers before with actual register pane, which is my favorite way to look at registers. You could do the R for a very, very quick look at some of the registers and what some of the values are. And of course, you could be specific to look at one specific register like RCX, for example. Okay, so stepping through an instruction. All right, one of the things that you could do is step into, step over. Okay, I told you the differences between the two, but the biggest one is when you're not at a function call. All right, let's just go ahead and hit F10. Everybody hit F10 real quick. Okay, there we go. All right. Yes. Okay, so here we go. We're not at a call. All right, so you have a couple of options. You could choose step into or step over. Either way, the result is going to be the same. You can't step into a jump, right? That only really comes into play when you see a call. Okay, so what we can continue doing is hitting F10, or behind the scenes, we saw the command P. All right, you could do .hh for P. And we see some of the details there for the step command. Okay, you can take a look at some of the different options, some of the different things that you can pass in there. And there's also, there's also a way to go ahead and step your way through all the way to a specific address, if that would ever be of interest. Okay, so we'll go ahead and hit F10. All right, I just like keyboard shortcuts instead of having to jump in there. And F10 pretty much work with whatever window you're in. You don't have to be inside of the command pane for that command to work. Okay, so we go ahead, hit F10 again. And then here looking at this call, this is when that big difference comes into play. We step into and step over. Okay, so we're about to make a function call, and we see the instruction call, and then we see the target of the call. And it tells us that we're looking for the module ntdll in the bang, and the function inside of that is RTL exit user thread, and it also gives us the address. Okay, what you could do is inside the disassembly window, you could go ahead and click on that, and boom, it'll go ahead and take you to that address where that function starts, and then you can start to see what's happening or what could happen for this. Okay, RTL exit user thread is very descriptive function name, kind of tells you what it's going to do. It's going to exit the current thread, whatever thread is calling this function. Okay, and then you can go through the motions and you can start to disassemble and have better insight into what this function is doing. Okay, cool. So I don't really care about debugging and looking at RTL exit user thread. So what we'll do is we will go ahead and step over. All right, so F10, boom, step over. Okay, so here we go through the motions and step trace thread exited, and call it terminate thread for that one. And looking at it here inside the disassembly window, we see there was a syscall that was invoked, and now we're at a ret. So at some point in time behind the scenes, there was a transition that was done into kernel land, and then now we're coming back into user space, judging by the look of the syscall stub here, nt terminate thread. Okay, so you continue to go and step it out, and boom. All right, so hit the ret, and we gave control back to notepad. Okay, so whatever thread was doing a thing, whatever thread we happened to be in at that moment in time, is now pretty much done. So we're probably in some other thread. All right, there's a hunch. Okay, so one of the things that you can do, and we'll take a look at how to view other threads later on in the series and switch back and forth in between threads and stuff like that. Notepad will have obviously at least one thread, but Notepad can have several threads at any given time. And a lot of times, let me go ahead and readjust my window here. And a lot of times applications will go ahead and kick off new threads based on interaction from the user. So if I want to go through the motions and save what I'm working on inside Notepad, because that stuff is super awesome, which is just gibberish, obviously. Okay, so it did save as, and this new dialog box opened up, and I can save it somewhere. It's like cool. And going through here, and we have a huge listing of events that just happened. And the type of event that happened is a mod load. Okay, so WinDbg is already set up to tell us whenever a new module has been loaded or has been mapped into memory. So we have a few things here, quite a few DLLs that have been loaded. Man, look at all these. Goodness gracious. All right, all those DLLs, I guess, play a part into the save as dialog box. Okay, and one little shout out for Pavel. This is an awesome guy. His GitHub repo is an amazing resource, a gold mine of custom tools that he's written. So check out his GitHub repo if you have time, especially if you want to understand some sysinternals types of tools and the code behind the scenes there. He's open sourced a lot of those, so it's really cool to check that stuff out. But in any case, when that happens, Notepad probably created 3, 4, maybe even 10 more threads to go ahead and load some of these other DLLs. And now that it hit cancel, some of those threads are probably on their way to being terminated or exiting because they're no longer needed. The DLLs have been loaded, all that jazz, and we're good to go. And just out of curiosity, hit break, and we'll do a new listing of modules. Yeah, quite a bit, huh? Quite a bit. Yeah, so brought in more modules to go ahead and give us everything that we needed to do to save something down to disk. All right, apparently it's a pretty complex task. More DLLs need to be loaded to go ahead and help us do that. Okay, so before going any further for this part of the series, again, this is just the beginning. All right, basically orientation to WinDbg itself, the interface, all that stuff, and some basic commands. All right, y'all, have a great one. We'll see you next time.